For our first problem, suppose that there are 18 runners in a race. How many ways for first, second, and third place runners to finish? And how many ways are there to hand out 4 good sportsmanship awards? Let's call this first question Part A and the second Part B. Part A is asking us about first, second, third place finishes. Because a first place finish is different from a second place finish. This question is asking about ordered lists, so permutations. Here there are 18 things to permute, and we want permutations that are 3 long. So we have 18 times 17 times 16, or if we wanted to see it in terms of our formula of 18 factorial over 18 minus 3 factorial, that would be 18 factorial over 15 factorial, which is exactly 18 times 17 times 16. And 18 times 17 times 16 is 4,896. So there are 4,896 ways for runners to come in first, second, and third place. In Part B, because getting the first sportsmanship award is the same as getting the second good sportsmanship award, this question is asking about who gets awards and not in what order they get awards. So this is a combinations question. Here we're handing out 4 good sportsmanship awards, and since there are 18 runners eligible, you have 18, choose 4. This will be 18 times 17 times 16 times 15 over 4 times 3 times 2 times 1. And again, in the language of our concise notation, this is 18 factorial over 18 minus 4 factorial times 4 factorial, which is 18 factorial over 14 factorial times 4 factorial, which is our 18 times 17 times 16 times 15 over 4 times 3 times 2 times 1. Here we notice that some things cancel out. 16 divided by 4 is 4. 15 divided by 3 is 5. 18 divided by 2 is 9. What we're left with is 9 times 17 times 4 times 5, which is 3,060. So there are 3,060 ways to choose 4 runners to get a good sportsmanship award. Our next example has us looking at a pizza shop that offers 12 toppings. If each week they make one 2-topping pizza half off, how long would it take to cover every 2-topping pizza? Additionally, if they wanted to do this, how many ways could they arrange the 2-topping pizza discounts? Let's call this first question A and the second B. In A, they're asking how long it would take to cover all 2-topping pizzas, and since we know that each 2-topping pizza would last for 1 week, the question depends on how many 2-topping pizzas there are. As we previously stated, this is a question about combinations, and we're choosing from our 12 toppings 2 of them. So we get 12 times 11 divided by 2, which we could again see from our concise notation, 12 factorial over 12 minus 2 factorial, 2 factorial, or 12 factorial over 10 factorial times 2 factorial, which equals 6 times 11, or that there are 66 pizzas, so it would take 66 weeks. In Part B, we see the keyword arrange, and we see that this is an arrangement, and what we're arranging is all 66 of these 2-topping pizzas. So if we think way back, we immediately know that the number of ways to arrange 66 elements, all 66 of them, is just 66 factorial, but to see that it fits our formulas, this would be 66, and we're trying to permute all 66 of them, which would be 66 factorial over 66 minus 66 factorial, which is 66 over 0 factorial. And this is why we noted that 0 factorial equals 1, so that we do indeed get that this is just 66 factorial. Here we could plug it into some computing device to find what 66 factorial is, but I'm going to claim that this is too big to really bother writing out. And that 66 factorial is perhaps the more descriptive answer, because numerically 66 factorial is a larger number than the number of observable atoms in the known universe.